Hello guys, welcome back to another video. In this lesson, we are going to cover how to give the names and identify acids and bases. Here on screen, we have the definition for how to recognize an acid. And whenever we're dealing with both of them, identify when we have an acid versus when we have a base. It's our number one step to figure out which naming rules we're going to follow. So how will we recognize an acid will be the following way. It's the fact that its formula will start with H, with hydrogen. So here on the left side of the screen, we have 5 different examples, and as you can see, they all start with the H, and they're all accompanied by either an anion or a polyatomic that have a negative charge. So let's go ahead and look at a flowchart. Because naming acids is really not too complicated as long as we know if we're dealing with a binary or a ternary acid. So binary from previous lessons, you might remember that we are dealing with only 2 different types of atoms, in different quantities, of course, but we're only dealing with 2. When it comes to the ternary acids, we're dealing with 3 or more different types of atoms. Now, here on the screen, you guys will see at the very top that it says, does the anion contain oxygen? Well, that's really when we're talking about binary or ternary. The presence of the oxygen will move it over from binary to ternary. So when we're dealing with binary, we're meaning we don't have any oxygen, we're only dealing with 2, usually hydrogen plus another anion. We will follow a very specific structure. We will have hydro, then the name of the anion, the ending IC, so ic, and then the word acid. And we'll look at a few examples in just a moment. When we're dealing with ternary, we will have an oxygen in the compound. Now, specifically, we need to know what is the ending of the anion. We're talking about the polyatomics. So we know that those polyatomics, they have a very specific name, and we know that they tend to either end in ITE or ATE. So having that list of polyatomics is extremely important, or hopefully by now we're becoming very familiar with some of them, so we might just know them from memory. So if we end in ITE, we will have the ending for the acid OUS. If we end our polyatomics name in ATE, our ending for the acid would be ic with the word acid following. So let's look at some examples. So the first thing we have to see here is we are dealing with naming acids that are binary, right? So we only have two specific, hydrogen plus someone else, a different element. Now, remember, hydro plus the second element, change its ending to IC, and then, of course, have the word acid at the very end. Let's look at some examples for that. So right here we have hydrogen in the first example with some iodide. So you can see at the beginning, we wrote hydro and iodine, right? Just like before, we were changing the ending to IDE. Now we're changing it to IC because we're dealing with acids. So hydroiodic acid. Let's look at the second example, H2S. We have, it's a binary, we're only dealing with 2 elements, right? Hydrogen and sulfur. And here we have hydrosulfuric acid because the root name is sulfur, so sulfuric. On the third example, we have hydrogen and bromine. Now we are not going to say bromine, we're going to say bromic. And because we're dealing with binary, it would be hydrobromic acid. So hopefully you guys are starting to pick up the pattern that we're following here. Now on this last example, we have hydrogen and chlorine. So we begin with the root hydro, and then chlorine changes to chloric, right? The ending, remember, IC, and then the word acid. So hydrochloric acid. So remember, this is only for binary acids when we're dealing with hydrogen plus one other element type. Now, let's talk about the ternaries because, again, the ternaries are the ones that will have oxygen in them, and also we can easily tell them because they will contain a polyatomic. So right here on screen, we have 2 examples. What happens to the name when we have ITE as the ending of the name of the polyatomic, or 8. So right here on the screen, we have NO2, which is nitrite. And as you can see on the flowchart, when we have an ending ITE, we change it to OUS. So nitrate as an acid will change into nitrous acid. Notice here, we are not starting with the prefix hydro, as we did in the other example. Because these are ternary acids, they follow a different set of rules. The only thing we're changing here is that ending part from ITE to OUS, as shown on the flowchart on screen. We do not, I repeat, we do not use hydro as a prefix when we're dealing with polyatomics, ternary acids. Now at the bottom, we have NO3, which name is nitrate. Of course, then we would then follow the other section of the flowchart and we would change into IC. So it would just say nitric acid. Again, we do not start with hydro because again, this is ternary, which involves a polyatomic and it has an oxygen with it. Different rules. So hopefully we are able to see the difference between our binary and our ternaries. However, that's not where it always ends. Like I mentioned already, we don't have a prefix. But for ternary acids, sometimes we might have more than the usual, okay? We just went over the example for nitrite and nitrate, turning into nitrous acid and nitric acid. Well, what happens if we encounter something like NO4 as part of it? Well, we have to then at that point use a prefix per. So what do I mean by that? Let's look at an example. HNO4 would turn into pernitric acid. This is important. Right here, nitrate has 3 oxygens. In our example, we have 4 oxygens. So the difference here is the fact that we have 1 more oxygen than the base, which is nitrate. So because we see that there is 1 extra oxygen in the normal nitrate that we would see on the periodic table and the polyatomics list, at that point we know then that we have to use the prefix per. So pernitric acid. It's the only reason we would use that prefix there. Now, these we don't encounter so often in our class, but it is important to know, especially we're hoping to move into more advanced chemistry courses. Now, naming bases. After all of that we just saw for the acids, naming a base is actually pretty simple. We really just follow one rule. We give the name of the metal, and then we give the name of hydroxide, which is the representation of having a base. So whereas before, to identify an acid, we would see that starts with the H, right? A base will end and have the termination OH, so hydroxide. So let's go ahead and look at a few examples. We have magnesium and the polyatomic hydroxide. So together are named magnesium hydroxide. Lithium and hydroxide would come together to form lithium hydroxide. So that's pretty much it for the naming rules, right? For bases. So let's take a moment right here on screen and let's attempt to first identify if something is an acid or if it's a base, and then after that, give the name of it. Okay, so hopefully you had a moment to kind of look at it, stare at the screen, do some note taking, and let's go ahead and just go down the list. This first one would be a base, and I know that because we have that termination OH. The second one would also be a base. The third one starts with H, so all the others. So we have base, and everything else is an acid. And I'm just using the letter of the beginning of the word so that I don't take too long. So let's go and now look at the actual answers for the names. So we have aluminum hydroxide, ammonium hydroxide. Something important here to note, this is also a polyatomic, but it is the one that has a positive charge of 1. So therefore, we can use it as a cation when we're building our hydroxides, our bases here. Then we have percarbonic acid. Normally on paper, you would see CO3, right? But we said if there's an extra oxygen, we would then utilize the prefix per. Now, we continue on. We have carbonic acid, chlorous acid, persulfuric acid, and again, that's another example. We usually have SO4, but because there's that extra oxygen shown here in the subscript, we have to use the beginning, the prefix per. So persulfuric acid. Then we have sulfuric acid, and the last one is sulfurous acid. And again, that's because one is sulfate, the other one is sulfite. So hopefully after this, we are now able to name our bases and our acids. We will move on in future lessons to start talking about some of the calculations that are associated with acids and bases. Thank you, guys.